We come back. The second part starts with a close look, very quick, to the oligopolistic model. I clean again our Jupyter environment. And when I start, now I choose oligopoly. One. Now is no more quick because we have 10,000 workers. We start with 10 entrepreneurs, and we have a network structure, and the plot of the network is slow. I can switch off the plot of the network because the order of plotting the network is at the level of the action of the observer. I simply delete this order and the plot disappears, not the network, the plot. Now I leave it just to show you 5 cycles as an example, because it is quite slow. Verbose, this is a choice. If verbose, it will explain anything is passing within the execution. So not nice, only useful when we start creating the mode. Verbose, no is the option. And it started. You see all the messages, the time series at the time 1, not time series, only the first point. We wait. It is calculating to display the network. Here you have the network. These are the workers, these are the entrepreneurs. The red one are unemployed workers. This is the ADHNC matrix, at the beginning is empty. And now the time series is starting to be created. And this is the plotting capabilities of Matplotlib with the legenda. The legenda can be on both sides because we have here 2 different axes. And so different legenda. And so on until the end. Now I wait until the end because I want to show you how I work. At the end of a run, you see that now some event is happening. This is the price decreasing dramatically, and the price of the unique good produced in this oligopolistic market. At the end, I save all the data useful for in a successively calculation to evaluate the result. Enter to conclude. 3 files with date and hour 2017 November 10 12 7 minutes 36 seconds written in the oligopoly folder. This is important to recover the different results. The files have always a new name because they have attached the date and the hour. Now we are no more interested in this sheet, and I close and Alt. And from here, I jump within the oligopoly folder. You see here, these are fresh files, just generated, containing the results of our simulation. In a simple way, CSV means comma-separated values. It's the simpler structure in the world. Data and the comma within them. If we have strings and a comma within them. There is a parameter file, a structure file, and a time series file. An example, these are the names of all the parameters and their value when the simulation was running. Just for memory. for us. I open this, notebook. I am using pandas, and I am using stats mode to make econometrics calculations. I am using the API, so the application program interface of this library to run the content of the stats model code within Python. I order to run all the cells. Now the program is waiting for a reply because, why? Where is it? Cell? Run all. Okay. Now I misplaced the run. Currently we have a unique file, but we can have in the folder more than the result of one run, several of them. And here I have to choose the file I want to elaborate. In our case, the number 0. And now I have all the parameters reported here. I have all the data. I have an econometric estimation of the result with a lot of not available number because I had only 5 points. And I have again the reproduction of the time series. In the end, someone yesterday was asking for tables in LaTeX. There is also the generation of the block to be copied within LaTeX to reproduce the table. The most important table is a correlation table. So I generate by IPython directly the LaTeX code to be cut and paste. A lot of time eliminated in my work. The table in LaTeX are wonderful, but you see, they are not so easy to be written by hand. It's a good idea to generate them automatically. For your information, there are more than 2 or 3 websites generating in LaTeX the structure of the tables. You put there your numbers, and they generate directly the LaTeX code for the table you have been creating. Nice, very useful. This is a huge, very huge model, and the making of it is documented online in a huge file. You see here, Oligopoly PDF is the, oh, sure. From here, I have no PDF, so I stop. From here, I cannot jump to PDF. I can jump from the folder. And I suggest to you, if you work on a large simulation model in Python, in NetLogo, in other languages, always to take a diary of your work. This is the last modification, it was in July. And here there are all the versions specified and explained. It's very important because someone in the world, we publish this work, can ask us, how do you have obtained this result? And if you are correctly working in the scientific world, you can reply, I don't remember, it was a program running, I don't know which computer, I lost the computer, I lost the file, I lost anything. Okay. You have to take a diary. And I have been only one day in Los Alamos laboratory to have a seminar, and they showed me their diary, handwritten, the diary. And they conserve all the diaries of their work. Anyway, this is a very important document for myself. And from here, I extracted the paper. The paper is a subpart of this, plus all the literature consideration, all the economics conclusion, and so on. But the kernel is this one. If you are interested in this example, here I have reported the general address. The general address is this one. Here you have the GitHub, the project you saw in Slack. The making of the paper, now it is online as a close to be published paper in this journal. The journal is not reported here, but it is Italian Economic Journal from Springer. And you have the paper online, but you cannot save it because Springer wants you to pay. But you can read. If we wait, it will be plotted in a nice way, I hope. Very strange. We have a good connection, but it's not. It's slow. Okay, maybe it is low. And you have the slide we prepared for a meeting, heterogeneous interacting agent, HIA. And in these slides, we have both the equation-based structure of the model. This is very important because if you want to discuss with other people, you have to show them the structure of your model. And then we start to discuss. This is the basis of the model. Now we have no time to examine it, but then the making, the presentation in a general mathematical way, and the making. In the making, each step has been documented, again writing the structure in a mathematical way. Because in a meeting you have the 19% of the people understanding that, and 1% understanding agent-based simulation. So you have to talk to people not understanding agent-based simulation. At the end, you jump to your result, explaining that your result has been generated following this structure of steps. All these steps are in SLAP, in the spreadsheet. And then, after showing the time series, showing a bit of calculation upon them. And this is the key result of this job. Is named counter-cyclical effect. And this is very interesting because it is theoretical impossible, but the simulation demonstrates that it can happen. Very nice. And in real world, it happens. In crisis, a few oligopolistic firms make more profits. And here you have it. So, I will not receive the Nobel Prize for that. But anyway, it is a satisfaction. And this is the added value of the simulation. To extract from a model more results than those that you can obtain in algebraic way. This is our added value. And I am close to conclude this conversation, now moving again to models. First of all, a general scheme to study simulation model. This is a scheme of mine, but other authors in the world have defined it because it is quite obvious, so it's not a specific idea of mine, it's an idea of mine, but subdivided with other scholars. And the idea is to represent our models always following this scheme. We have an environment, we have agents, the agent have rule, the rule can evolve. Sure, if I have fixed rules, this does not exist. This is a rule master the brain of the agents. An example, eat, nothing to eat here, this is the rule. Search for food, something to eat here, and this is the evolution of the rule. How we can evolve the rule? As an example, by learning. Learn, modify the content of the structure, usually with neural networks, with very good results, with improvement in the behavior via learning, or running our models within a genetic algorithm structure. This is easy in NetLogo because the authors of NetLogo have prepared a shell named behavior search, which is a structure of genetic algorithms running NetLogo models. A nice example is from my own page. In my own page, I report all the research theses of the students working with me. And Luigi, in October, has discussed with a very good result his thesis about emerging cryptocurrencies trust in an agent-based model. How people can trust or not a crypto money. And the joke was that The Economist had published a short article explaining that very few people in the world are able to guess if money will succeed or not. Very few people plus Luigi. Okay, this was the joke. Anyway, the thesis is very, very good, and it is using genetic algorithms to evolve the parameters of a NetLogo model with or without the emergence of trust for the new money. Out of my competencies, I guess that we are close to a disaster with the Bitcoin because the bubble is now incredible. This morning, $7,000.
I earned 2,000 euros.
Sorry?
I earned some money with it, so I don't care. I already sold all my Bitcoin.
Very good.
Yeah.
It's the same as in the Middle Age, the bubble of the tulips. It's exactly the same. Anyway, the thesis is very good, and it is based on NetLogo, but with the use of genetic algorithms. So we can evolve rules, and this is very important. We in our life continuously evolve our rules. How to obtain a result? By trying and learning. You have very important other NetLogo extensions. This one is connecting NetLogo to R. This is a learning example. I will show you if we have time. This is a very nice extension of NetLogo using BDI agents. BDI is from psychology, agent able in beliefs, desires, and intentions. This is one of the structures that psychologists improve, not the main one probably. And I had an experience with colleagues coming from with a colleague coming from psychology. He was explaining that by learning, my agent were able in doing something. I don't remember. Why they do that? The question. Why? Because I told them to do that. Not interesting. Correct? We have to explain why our artificial agents, following their desire, their beliefs, their evolving goals, and try to execute all the action to reach this goal. Very complicated. And this BDI structure is a step, small step in that direction. A new project that I have discovered a few days ago is the idea of running NetLogo code from Python. So you have a Python shell, and you use the structure of NetLogo to do something, and you obtain the result in Python. It's a newborn project, but it is in any way interesting. Other example for your future interests, you maybe remember that I told you that NetLogo is coming from Logo, but originally the idea of running in a parallel way several Logo projects was from MIT people. And they named their structure Star Logo. Then they separated. A group of them went in Northwestern University in Chicago, and they started evolving NetLogo. Then people from Stavlogo reacted, adding TNG to their name. TNG is for the next generation. Why next generation? Because it is producing a wonderful graphical output, close to a video game in 3D. Very expensive to be created, a lot of work. But the result is very nice. And if you wanted to interact with the politician, with the boss here, I understand the papers. But a former PhD of mine, a wonderful student, she's working in the Bank of Italy, tried to explain to one of their very huge bosses that to control the money payment among banks, it was necessary to evolve an agent-based model. If you look in my papers, there are, I guess, 2 papers. One I will show you now, because then we started working together. And she wrote a paper to explain that with the agent-based model, it should be possible to understand more than with an equation-based model. The boss wrote on the paper, not interesting. She is very able in taking a role, and she created in StarLogo TNG a model close to the video game. Asked for 10 minutes to show to the boss the model, and the reply was very interesting. Do that. The difference between a paper and a video game. Attracting and immediately explaining the content. In the case of these video games, the payment were small balls, green if on time, red if delayed. All the banks are around the Bank of Italy. One of the banks, for some reason, stops making payment, and quite immediately all the payment, not all the from that bank, all the payment are becoming red. And the Bank of Italy has to put liquidity in the market. Very nice. Immediately possible to understand. But there is a huge quantity of work you have to do that. And also the people from MIT decided to move to a new way of programming. They started from this toy. This is to teach computer science to young persons, moving a cat of the cartoons, Felix, the Felix cat, around, with a completely graphical structure. This is easy to be used. But as you multiply your structure, it becomes very difficult. This is the structure, you see? Repeat, move, change, play, and so on. Like a puzzle. You have small pieces to be put together. And the program works. But as you have a plane like this table filled by these small pieces of code, you understand nothing. Because you have only a small window moving upon the program. Anyway, have a look, it is very interesting with Felix. This is Felix. We have a lot of different environments, all coming from the original idea of Swarm. Repast is very diffused. It was written in Python, then in Java, and is directly coming from the Swarm idea. And the authors are from Chicago. And in the beginning, Epstein and Axtell were working to this project. We have Mason project of George Mason University. Axtell is there. Epstein and Axtell are two great originators of the agent-based field. Gamma is the code I was trying to quote yesterday. I had forgotten the name. Gamma is used here in Torino for the master degree of physics of complex systems. It's very powerful, but completely undocumented and completely obscure. So you have to understand it fine. Very powerful. Any logic using together agent-based simulation and other simulation tool like differential equations is very powerful, but you have to pay to use it. It's costly. And you have online here an example. No, a lot of examples in their cloud. You can look at them without installing anything. A recent example in Python is Mesa. Is new, it is quickly developing. We hope we will have a new tool. Close to finish. I report here a very nice link to a set of cheat sheets, to cope in class. No. To memorize all the structures. Have a look, it is very useful. Advanced R with RStudio, Python, NumPy, and Pandas. One A4 page. So you print it, and you have all what is interesting to be remembered after you have studied, because if you have not studied it, you understand nothing. But anyway, they are very, very useful. We have to be a lot grateful to the authors. A lot of work. Now, a look to a paper of mine. You see here, Arcero, Piccillo are people from the Bank of Italy. Sorin Solomon is a professor in physics in the Hebrew University of Jerusalem, and Terna is myself. In a book of 3 years ago, and the conclusions are very interesting. The conclusions are from the pen of Sorin Solomon. You have the paper online, and the conclusions starts. I have in yellow. Start from quoting Trichet. Trichet is the former president of the European Central Bank before Mr. Draghi. And as a policymaker during the crisis, this has been written 7 years ago. Yeah, in 2010. I found the available models of limited help. In fact, if we will go further in the face of the crisis, we felt abandoned by conventional tools. So we have to try to develop new tools. One of the possibilities, I am not sure of that, but one of the possibilities is ABM simulation. My oligopolistic model is close to a DSG model, Dynamic Stochastic General Equilibrium model. And we demonstrated that it is possible to try, I use a defective presentation, to try to build a agent structure. Again, Trichet, agent-based modeling dispenses with the optimization assumption and allows for more complex interaction between agents. Trichet told that, and I have diffused this paper to everyone. Sorin Solomon, the difficulty of applying precise mathematical theorems to imperfect concrete reality has also complicated the application of academic results to policy and decision making. Because in the end, how we work to improve policy and decision making. This is our final goal. Okay, have a look to the paper. Here you have the structure of the result of the crisis of liquidity in payment, and here you have my usual scheme. You know it. Okay. Just to finish, this is a very important question. And maybe you can reflect upon this sentence, this question, when you will be writing the essay for the exam. A lot of people in the meetings ask me, how do you have calibrated your model? Do you have used actual data? Actual data coming from, and so on. My reply is, yeah, I try to calibrate it with actual data, sure, because it is interesting, but it's not the key of my work. The key of my work is to build reasoning machines. What a reasoning machine is. When we have an agent-based model, we are comparing a set of ex-ante proposals. Our agents are behaving this way, this way, with the results emerging from the simulation. We could do that without the computer, simply reasoning, but it is too complicated. We are lost in the ether. Professor Schelling, when demonstrated the emergence of segregation in people looking for a minority of equal persons, this is an interesting result. I want to be together people with the lenses. I want 30% of people around me having lenses. At the end, we will have two parts in the class. People with lenses and people without lenses. The segregation. Emerging without our goal. I want only my goal. Professor Schelling demonstrated this with an agent-based model elaborated by ants. Computers in the 70s were too costly. But for my oligopolistic model, doing that without a computer would require a few centuries of work. Okay? So computer is helping us in automatizing reasoning from ex-ante to ex-post situations. And for me, this is more important than spending a lot of days or nights in calibrating the model. Sure, if the research question is how many liquidity I have to put in a day where liquidity is missing and 3 banks are not paying, I have to calibrate and to try to have quantitative replies, but in the majority of the situation, we are interested in qualitative results. Reflect upon that. It's a very important question. Here, in next week, we will start including agents in networks. You will be exposed to two levels of teaching, that of my friend Martin Kashai, with the theoretical mathematical basis of networks. He's a wonderful teacher. And from myself, you will be exposed to the attempt to consider the nodes of a network as agents. Agent behaving in the agent-based perspective. This is possible both in NetLogo and sure in Slapper, because we had in mind that when they started creating Slapper. Again, it's an interesting adventure in your learning phase of this kind of problems. And last of all, also the second course will be concluded by sure. Now we stop and we prepare to go to the restaurant. If you want, we can go together.